Welcome back to the channel. Today, we're diving deep into how the .NET garbage collector manages memory using generations. Before we get started, don't forget to like this video, subscribe to the channel, and hit the bell icon so you never miss a tutorial on .NET and advanced programming concepts. In .NET, every piece of data lives either in the stack or the heap. But what's the difference, and why does it matter? Let's break it down. Let's talk about stack memory in .NET. The stack is a special region of memory used for static memory allocation. It stores value types, method call details, and references to objects in the heap. What makes the stack unique is that it works in a last-in, first-out (LIFO) fashion. When a method is called, its local variables are pushed onto the stack, and when the method ends, they're automatically removed, making allocation and deallocation super fast. However, the stack has a limited size, so using too much memory can cause a stack overflow. In summary, the stack holds value types like integers and structs, method call frames, and references that point to objects in the heap. Now, let's look at the heap memory in .NET. The heap is a much larger region of memory used for dynamic memory allocation, and it's fully managed by the garbage collector. Unlike the stack, the heap stores reference-type objects like class instances, arrays, and strings. Every time you use the new keyword, the object is created on the heap. Memory management here is more complex. The garbage collector automatically frees unused objects, but this comes with a bit of overhead, making the heap generally slower than the stack. Another key difference, there's no fixed order. Objects can live as long as references exist, whether that's milliseconds or the entire lifetime of the application. In short, the heap stores objects, strings, arrays, and large objects, while the stack just holds the references pointing to them. Here's how the stack and heap work together in .NET. A value like X lives directly on the stack, fast and temporary. But when you create an object like P equals new car, the reference P is stored on the stack, while the actual object lives in the heap. In summary, the stack is fast, short-lived, and stores value types and references. The heap is slower but long-lived, storing the actual objects, all managed by the garbage collector. When does garbage collection trigger in .NET? As your application keeps allocating objects, the managed heap can eventually fill up. When the runtime encounters the new obj instruction but finds insufficient memory, the garbage collector automatically steps in. It scans for unreachable objects, reclaims their space, and compacts the heap for efficient reuse. That's the core rule of garbage collection. It only runs when memory is needed. How the garbage collector determines if an object is live. The garbage collector starts by checking roots of reachability, stack variables, GC handles, and static data. It then builds an object graph, tracing all connected objects. Anything not connected is marked as garbage. Even circular references are handled automatically, so no leaks like in COM. Finally, the GC sweeps unreachable objects, compacts the heap, and updates references. In short, roots define what's live. Everything else is collected. In .NET, not all objects are treated the same. Welcome to the world of generations in garbage collection. In .NET, the heap is divided into generations to make garbage collection more efficient. Generation 0 holds newborn objects. Most die quickly, like temporary strings or method-level variables. The garbage collector runs here most often. If an object survives, it gets promoted to Generation 1. Generation 1 is the teenage stage. It acts as a buffer between short-lived and long-lived objects. If an object survives here too, it moves to Generation 2. Generation 2 is for long-lived objects like UI forms, configuration data, or caches. Garbage collection here is less frequent, since scanning Gen 2 is expensive. Large objects also go directly here. By focusing collections mostly on Gen 0, .NET makes garbage collection faster, efficient, and scalable, handling both short-lived and long-lived workloads smoothly. Finally, .NET divides objects into generations. Generation 0 for short-lived, Generation 1 as a buffer, and Generation 2 for long-lived or large objects. Most objects die in Generation 0, making collection fast and efficient, while Generation 2 keeps your application stable for the long run. Now you know how .NET manages memory with Stack, Heap, and generations of garbage collection. If this video helped you, don't forget to like, share, and subscribe to stay updated with more deep dive .NET tutorials. Thanks for watching, and I'll see you in the next video.